Hopefully you're all fine with that. One of the things we do with webinars in this series, and I'll explain the series more here in a minute, is post these for future viewing and share these with our network. Many of you are probably aware of that network because we did most of our promotion for this webinar through the network. So our EA Post grant, which is a National Science Foundation funded grant project to do faculty development, outreach, material development, kind of all things under that realm in the introductory statistics curriculum space. My name is Nathan Tintle. I'm fortunate to serve as PI of this project with a wonderful team of folks who help run things. And today we're really excited because Julia and Nicole are going to present, and Julie and Nicole are both participating this semester in our EA Post Scholars mentoring program. And what this does, for those of you who may not be familiar, is anyone who's part of our network, which is everybody here. If you come to something like this, we consider you part of our network. Do some professional development, learn some things. If you want to be paired with a mentor in a future semester, I'll talk more about this at the end. We can, explore that with you, but essentially pair you with one of our experienced teachers to partner together and talk about how to do statistics, teach statistics differently in your class, content, pedagogy, anything goes. These are meant to be sort of rich one-on-one or sometimes one on a few mentoring opportunities that really allow you to dig deep as a teacher with others who aren't at your institution, maybe you've never met before, and kind of brainstorm and then try some stuff and then talk about it. And that's what we're here to do today. So Julie and Nicole are going to talk about some of the things they've been doing in their classes just this semester. Probably a little bit of the good, bad, and the ugly. What went well, what didn't, lessons learned. And so we're excited to have them share about that. Just in terms of a little bit of logistics, as I already said, this is being recorded. We'll post this for future viewing by any of you or anyone else in our network in the future. Roughly half our time, we've got about an hour blocked off, a little less than that. Roughly half the time with Julia, half the time with Nicole. So figuring they'll present for 20 or 25 minutes, have some time for Q&A at the end. Appreciate everyone looks like they're muted. That's probably the way to stay. That is the way to stay while the presentations are going on. Feel free to use the chat though as we go. Feel free to put questions there. If I see anything that's of particular note, I may interrupt Julie and Nicole and mention it. Otherwise, we'll just keep questions for the end and either interact through the chat on those, or you can feel free to unmute at the end. It's a small enough group that we can do that. So with no further ado, Julie, I'll turn things over to you. Julie is at Haverford College, and take it away, and I'll stop sharing.
All right. Thank you so much, Nathan, and thanks for the opportunity to present today. Let me get my slides going. Okay. Does this look good to everyone? I can't see people anymore.
Looks good.
Okay, thank you. Great. So yeah, I'll be talking a little bit about how I use real data in the classroom this semester. So as Nathan mentioned, my name is Julia Costa-Curta. I am a new visiting assistant professor in the Department of Mathematics and Statistics at Haverford College. I'll get a little bit more into the college and class context in a bit, but I was mentored this semester by Soma Roy. So yeah, I'll be talking to you about teaching with real data, with the asterisk that I'm about as starting out as you can get. This is my first year teaching at all, really, and then also in this class. So I'd love to hear suggestions that you all have as well. Okay, so a little bit on the course context. So as I mentioned, I teach at Haverford, and the course that I'll be talking about is Math Stat 103, which is our introduction to probability and statistics. So Haverford is a small liberal arts college, so I had about 20 students enrolled, which really kind of helped with the classroom environment. And this was my first time teaching introductory statistics. So a little bit more about the specifics of this particular class. So this is a little bit of a special class in that it's only available for students who specifically have not taken Calculus 2, and it doesn't serve as a prerequisite for instance, if they wanted to take regression later on. And so what this means is that the students who are enrolled are primarily freshmen and sophomores, and there's many pre-med majors. But what this also means is that this is kind of the class that students take if they don't really consider themselves to be like a math person, but they want to get, say, maybe take a math class or do a quantitative breath requirement or something like that. And so looking at all of this, how I view the context is that students don't necessarily consider themselves to be math people who are in it kind of for the sake of the math. And so it's really important in this context to present the material in a way that's engaging to students who, again, are in the classroom for a lot of different reasons, and mostly not because they love math a lot and have had great experiences with it in the past. So I want us to keep that context in mind as we go through these examples. And so I'll be talking to you about how I use real data in the classroom. And so we can take a moment to think about why it's important to use real data. And so I'll first turn to the 2025 GACE recommendations for teaching introductory statistics and data science. And one of the recommendations is to integrate real data with a context and purpose throughout the course and to select data that are meaningful and engaging to the students. And so this is kind of a broad recommendation, but I imagine that those of us who have taught probably have some intuition that students are more excited by data that is real and relevant. Like if we turn to something that is data from, say, current events, the students kind of perk up a little bit and start to pay closer attention to data that they view as relevant and current in their lives. And the other thing that I've noticed is that I found I'm also more engaged in my teaching when I show this type of data. So as you all probably know, like students have a really good sense of when you're teaching something and your like heart's not in it. And I found that when finding this real data and putting together these exercises myself, that also helps me, show that I'm engaged with the subject. Okay, so what I'll show you today and kind of the outline for the rest of this talk is I'll show 5 specific examples of how I used real data in my course this semester. Now, these are not necessarily like I didn't collect any of this data. It's just data that I either ran across in the wild or thought of or saw in a mailing list recommendation or something like this, but they're ones that worked decently well for me. I'll give some context, so when and kind of how in the course did this data appear. I'll let you know what I asked my students to do with the data. And then I'll get into kind of, when possible, the source, the like URL source for the data and other potential data that you could use in its place, say if it's very location specific or something like that. And then I'll give a brief example of scraping tabular data from a particular website using the pandas read HTML function. So this is kind of what I found to be the shortest path to reading in data. Okay, so I'll go ahead and get started with the examples. So the first case is weather data, and in particular, snow. So this was really early in the semester, so back in, I think, early February, and I assigned a homework question in our data visualization and data summary statistics unit. So you can see on the right-hand side, we've set up this example called January snow, where I grabbed data for the snow in January per year for the past like 20-ish years from a station that's very close to my college. So we are located very close to Philadelphia, so a lot of these examples will have to do with data from Philadelphia. So we can see this data in the table here. And what I asked my students to do was to calculate the average amount of snow in January to get more practice with calculating the mean. I asked them to draw a normalized histogram using bins that I had already pre-specified. So they have to count which data goes in which bin. They have to calculate the proportions and then calculate the heights for a normalized histogram. I asked them to confirm that the histogram area summed to 1. And then I asked them to then compare this year's snowfall to the histogram of historic snowfall. And we actually had a lot of snow this year. I don't know if there's any other folks on the East Coast, but there was a lot of snow. And so I thought it was a really interesting way for the students to show that it was an unusual year from data rather than just kind of anecdotally. Now, if you're not in a place where snow is super relevant, you could also consider using rain, like the number of sunny days in a month or something like that. But this is something that, is maybe pretty low-hanging fruit, but maybe that's not a bad thing. Like this is weather data that the students are living, and so it can, I found that using this type of real data was really interesting. And I'll share these slides after we're done today, but this is the link to the government website where you can kind of get this data for your use. Okay, so for my second example, so this was an Olympics year. So I decided I wanted to collect some data from the Olympics for use. And so the context was the first midterm, and particularly I wanted an example of a left-skewed distribution, which if you've gone trying to Google for plots that show a left-skewed distribution, it's actually like deceptively hard. Most of them are right-skewed if you find something. So if folks have other suggestions, I would love to hear them, but this is an example that I found of a really kind of nice looking left-skewed distribution. And what I asked the students to do was to determine, the skew and then whether like different characteristics of this distribution. I asked them to then find the bin that contains the median using the information only contained in this histogram to say how the mean would compare to the median given the skew, and then matching this plot to the corresponding box plot out of a couple different options. And I found actually that question gave the most variability in student responses. And so it was interesting to see kind of whether they could map from one to the other. So every other year is an Olympics year. There's not always going to be the ski jump, but you could also consider using like race times, distances from the long jump, stuff where people kind of max out at a particular distance. So like people kind of max out around here, but there's a larger spread kind of below that max value, I think led to these nice like left skewed distributions. And the data is from this Olympedia like Wikipedia website, and I scraped it using pandas. And I'll go through an example shortly of how to go from kind of 0 to this plot in a couple of lines of code. Okay, so for case 3, I made a homework question about Groundhog Day. So for context, this was very late in the semester, so this homework is actually due in like 45 minutes, but I asked them to do a randomization-based hypothesis test. And if you're not familiar with Groundhog Day, it is a regional holiday. There's also a movie made up with the same title, but the regional holiday is that out by Pittsburgh, there's a city called Punxsutawney that has a groundhog who has allegedly lived for over 100 years. And every February 2nd, they go out and take the groundhog out of its hole and check to see if the groundhog has observed its shadow or not. And then they use that to make a prediction about whether spring will come early or if there's 6 more weeks of winter. So with that all in mind, I was thinking about this kind of on the train on my commute, and I realized this is actually a really nice situation to do a hypothesis test because we have this label of more winter or early spring, and then weather data, as we've already seen, is pretty easily available. So what I asked the students to do was to set up and conduct a randomization-based hypothesis test for determining whether there's kind of any relationship at all between what Punxsutawney Phil has to say and what the weather in March, so the month after the prediction, actually is. And, spoiler, he's not that good at it. So, yeah, so this was a kind of Pennsylvania specific example, but in my research trying to find this data, there's actually a whole listing on the groundhogday.com website of prognosticating animals that are said to predict the weather. So, chances are there's someone who is closer to you than Phil if you'd rather use a more local example. And I scraped the predictions from the site above using code very similar to what I'm about to show you. And I grabbed the average March temperatures also from the NOAA. Okay, 2 more examples. So this fourth one, I really love using kind of plots from news when it's applicable. So these are called kind of straight from the headlines segments. And the context was that this was kind of mid-semester in our correlation and regression unit. And so my student tasks were, so I'll pause for a second to just look at these plots on the right. So in the upper right, we have a plot that is trying to associate age of death with musical genre, which is in kind of a regression looking thing, which is a little bit already maybe a little bit suspect. But on the bottom, there is this plot that's showing the construction costs of nuclear reactors in terms of dollars per watt for 2 different countries represented by the colors. And then they fit these regression trend lines to each set of data. And so what I asked my students to do was to identify the observational units, the variables, and then possible trends and outliers in each plot. So just to kind of get us situated. And then I wanted them to think about, what do the creators of this graph want you to take away? If you're seeing a graph in the news, it's because there's a takeaway that the creators want you to think about. And the way that I framed it specifically for them was, what if you were kind of in bed scrolling Instagram and you kind of paused at a plot like this? Like, what would your takeaway be, right? Because that's a situation that they may find themselves in. And if relevant, you can include a quote from the corresponding article and ask students to critique. So both of these articles actually had interesting quotes of the authors claiming something that doesn't like quite maybe follow the story that is in the graph. And I found that this is a really nice example because the students like love to critique graphs, like and especially graphs that are published in the bottom ones in the New York Times. So teaching them a little bit about how to kind of digest these plots in a critical way. And my sources for these, oops, my sources, so the bottom one, I saw this on the ISI-Stat mailing list, I think last semester. There was a discussion about it when it was published, but that's from the New York Times. And then the top one is from the conversation, but I found it in the course materials from the course Calling Bullshit taught at University of Washington, which is, it didn't map like 100% to the class I'm currently teaching, but they have a really nice set of materials for kind of data literacy and, as you might expect, kind of calling when things don't quite make sense or claims aren't quite backed up by the data. So those materials were very helpful. Okay, so my final example is the survey data. So on the right, these are two exam questions. So the first question was on or from the second exam. And then this question 4 on the bottom is actually from their final, which they're going to take next week. So please do not tell my students about this. But for context, it was mid-late semester and we were doing contingency tables. And then this data also carried over into kind of our hypothesis testing unit. And so what I asked the students to do was to fill in missing entries of a contingency table. I didn't do that in either of these questions, but if you have your total columns and rows, you can kind of delete some numbers and get them to figure out what should be there. Calculating probabilities. So you could frame like if we picked a random respondent, what is the probability they said X? And then conducting hypothesis testing like in the example below. So I got this data from a few different sources. So the one at the top, this was data that a local researcher actually collected a random sample of folks in Philadelphia and in Seattle to compare their reactions to driverless cars. And I thought about this because I live in Philadelphia and recently there have been Waymos around. And I thought this was really interesting because the way people drive in Philadelphia is not necessarily conducive to driverless cars, but they're trying. And I was curious if there had been any research done on this. So I unfortunately can't share this data directly, but the lead researcher got back to me very quickly when I reached out to ask about the data, which was really just a nice interaction. And then I had this data to show the students that was very kind of localized and currently relevant. And then the other sources that I've gone to, these are pretty standard, but the General Social Survey and the American Community Survey are two services that have pretty nice interfaces for getting data. So I got the data shown in the plot in the second question from I forget which, or yeah, from the General Social Survey. Okay, so now what we'll do is I'll go through an example of scraping data from the Olympedia website. So I will show this QR code and maybe I'll type the link in the chat as well so it's a little easier to get to. And I don't know where the chat went. Sorry. If someone can type it in the chat, the way I have my presentation set up, I can actually see the new.
I'll put the link in, Julia.
Thank you. Okay. Cool. I'll wait like 10 more seconds and then move to my screen.
It's in the chat now.
Thank you. Okay. All right. Cool. So this is the example that I've put together for grabbing data from this URL. So we'll take a look at it for a second.
Did you still
Oh
want
my
to be
goodness,
sharing
I'm
your
not
screen?
sharing. Thank you. Okay. Okay. So this is the page that I'm pulling the data from. So you can see this is the Large Hill individual men's event from this year's Olympics. And you'll see a few tables. So there's this first table. I wanted the distances. This actually isn't, there was some kind of mapping between distance and also like points from the judge that didn't quite anyway, it didn't quite get what I wanted. But down here, we have the distance for the round 1 jump and then also the final round jump. So there are 2 jumps. And so if we go back to the collab example, we'll load in a couple packages. And then we use this we type our URL and use the request.get URL to extract the information from it and then put it into the pandas read HTML function. And they're recommending they're going to deprecate putting the URL, putting this response indirectly. So this is now the way to do that so you don't raise an error. And then if we just take a second to look at this, we'll see that what Pandas has done is it's read out. So this is our first table that we saw on the website. And there's a few other ones. But let me just make sure it's okay. Let's see. There's a couple different tables that we could grab depending on how we index. But sorry, my collab's taking a second. But I don't have a great way to do this automatically. I just manually looked for the tables that I wanted after I'd read the HTML. So this was one of the ones I was interested in that had actually the raw distances in it. And then I grabbed those two tables. So this is the table for the second jump and then concatenate them so that we end up with a nice big table with all of our jumps in it. So scroll back up for a second, but now we have 80 rows. So we've concatenated all of our jumps. Sorry, this column is the one we want. That we've concatenated all of our jumps together. So then I converted the distance data to numeric because it wasn't already, and then dropped nans. And you're already ready to make a histogram. So from there, you can use the built-in pandas functionality to plot the histogram, or you could use matplotlib, whatever is more comfortable. And then I left this line. You can uncomment if you want to save at a higher resolution because the way it auto-generates is not at the best resolution. And you can pretty up the graph however you'd like. I changed the style around a little bit. So there was a grid so students could read off the heights a little bit easier. But yeah, so that is my example. I'll jump back to the slides for the last few minutes. That is my class. Sorry, give me one moment. Okay. Okay. So my takeaways and what I'm thinking of moving forward. First, as always, curious about my students' thoughts. And I actually am not sure yet. So it was our last day of classes today. I asked my students in the feedback form for the course specifically about the data that we considered, like stuff they liked more or less. And so I will know in a couple of weeks, but for now, results TBD. But just anecdotally, I did notice that they seemed more interested in the problems that had applications they cared about. So not all of the data was necessarily stuff they cared about, but I think there was slightly a higher hit rate with real data. My own thoughts were that the process of finding and presenting this data in discussion with my mentor, Soma, has given me a lot of satisfaction that I found has been worth the extra time. So, I found myself thinking about, oh, this would actually be a really cool example to use in class. And it is actually possible to go get the data and code up the example myself. And even though it took a little extra time, I found that it was really made the experience more meaningful. In general, what I've learned from this semester is that finding real data is feasible and makes examples and problems feel more meaningful. So when you're thinking about data, you can consider data from events or studies that are seasonal or location specific. So weather and city surveys, if there's a large or even a small city near you, maybe they collect data and have it publicly online for folks to look at. And also just elections, sporting events, seasonal stuff as well. And so my parting question for you all is, are there any sources that you turn to for data for the classroom? Maybe either I know that the sources that I listed are not reinventing the wheel, but they're also not comprehensive. So if there's anything that folks really like to use in their classroom, I would love to hear it so that we can continue to build resource for sharing and avenues for sharing this kind of data. And while folks are kind of typing their responses in the chat, I'd like to just say thank you to everyone for being here. I'd like to particularly thank my mentor, Soma. It's been a really, really wonderful semester, and I felt very well supported, kind of setting out to teach intro stats for the first time, which was a little intimidating. I'd like to thank the entire EA Post team for the support and I also attended a workshop, so just like the really wonderful resources you're putting out in the world. The stat ed community, so I am really new to statistics teaching. My PhDs and degrees were not in statistics, actually. So I'm pretty new to this community, and I've just been welcomed with such open arms that it's been really lovely kind of meeting and working with people. And then finally, thanks to everyone for attending. So with that, I will stop sharing so I can look at the chat and see if folks have more data they'd like to share. Oh, no, okay, not yet. Well, thank you
thanks,
all.
Julia. But yeah, just encouraging everyone, yeah, feel free to share in the chat where you're grabbing data from or other questions for Julia. I guess I'll maybe kick things off with a question for you here while we're waiting for others. I guess, you talked about that kind of the process of finding data, right? And then I think you used the term, meaningful for you. And I guess I'll say my comment is I think that enthusiasm you have for it as an instructor carries over into the classroom with your students. I mean, at least that's my sense. Like if I've put some time in and invested in it, I think that has a carryover effect. But my question for you is, you know, I have found, and I'm curious what your experiences are, that sometimes it can take a while to find the right data set, especially if like I want to show this specific thing. So can you just comment a little bit about that process and maybe some of the twists and turns that got you to the data sets you used?
Yeah, for sure. Yeah, I agree with that. I think like sometimes I would just like there was I was trying to look for an example of something that's log normally distributed, and it was just taking forever. And I finally like kind of messed around a little bit with like a YouTube comment length data set or something like this. But like there were times when the time I was putting in, I would just decide to kind of call it and go with a more kind of standard example or one that I had already seen, even though if I personally found it a little less exciting. But a lot of these like happened kind of organically. So the Punxsutawney Phil one was one that like when Groundhog Day came around, I realized that that would be a really fun example, and there's probably data for it out there somewhere, and it's actually quite easily accessible. And then with the Olympics data, a similar story of just like watching the Olympics and realizing, wait, there's so much data being collected right now that I could use in class. And I found actually that like once I found that data and like scraped it and had it, then I could create exactly the plot I wanted, which was so satisfying. Whereas I spent a lot of time also Googling around for like left skewed distribution real data. And like that actually was a lot less successful, I found, than like kind of casting a net without really knowing what I was looking for.
Mm.
Like, so I don't know if that helps. But yeah, that was kind of my experience with finding these examples.
Yeah, I think that's great. Well, I think we'll transition over to Nicole, and I'll just encourage everybody, if you have additional questions or thoughts for Julia, feel free to put them in the chat. We'll maybe have time for more questions for both of you at the end, but I do want to be respectful of the time. And so, Julia, thanks so much. And
Thank you.
Nicole, at Lynn Benton Community College, we will turn things over to you. Take it away.
Thank you. Let me open up my slides. So it was really great to hear your talk, Julia, actually, because I was totally intimidated by web scraping, and I'm super excited about all of the things I just learned, and I'm going to implement them next term. But I am also new to teaching statistics, and this year was the first time I have taught statistics, so my background's pure math, and I had a elementary statistics, which is for our gen ed math course for any student, and we were using a textbook, Intro to Modern Statistics, and the technology we were using was our guru. And I had read the GAE's recommendations and saw that I should be integrating real data with context and purpose throughout the course. And they had all these great recommendations, but it didn't yet quite have all the links yet of where you might go, and that now there's the Gaze recommendations have a lot more resources, but at the time there was less, and I'm like, oh, how do I do this? And so I just struck by the relevance, actually, finding things that were engaging to students, because I'm not a big sports person and I wasn't sure which of my students would be and which wouldn't be. And I just felt kind of at sea. Fortunately, the US Conference on Teaching Statistics was happening in the US last summer. And so I went there, and there was a great workshop and they talked about using real data in the classroom. And Beth Chance was one of the plenaries, and she presented some things, and it just gave me just a few little lifts that I needed. And so one of the biggest things that was like my first lift into my first term in the fall was just that class survey. And I knew people did class surveys, but I didn't know how to use it. I didn't even know what questions to ask. And so I frantically copied down what Beth had shared during the US Cause plenary of what she was asking students. And I asked those questions and saw that she had this great activity that I think came from, I'm going to have to move my pictures. All pictures are covering just a little bit of my slide. Activity-based statistics was what it was originally from, where you match the survey data that you have to dot plots. And so it was really nice just at the beginning of the term before, like the way Intro to Modern Statistics tells the story is you do study design and then and sampling methods, and then you move into descriptive statistics and visualizations. And so we had the survey data, and just one of the days in class, we had cleaned up the data and put them on just like sheets, blank, like nothing on there, no labels, just one sheet per question, and handed them out to groups and said, we forgot to title and label our graphs. Help. And so then students and groups just worked together, and it was such a great, they had seen a dot plot once before, but it was just such a great experience to see the students recognizing which dot was their dot and connecting, the difference between what would look categorical and what would look numerical and continuous and labeling. So actually the way I did the activity was they were kind of competing as different table groups. And so they got a point if they matched it to the right question, and they got a point if they somehow got close to the right scale. And the haircuts always got them. They'd be like, who spends $350 on a haircut? Because that outlier, they just wouldn't believe it was so high. But they were really good at people preferred Coke over Pepsi, or and this one I didn't have any ambidextrous, so they were like, yeah, we probably have less left-handed people than we have people who are preferring Pepsi. And so they actually did a really good job of matching the variables, and the scale gave us a lot of interesting information and conversation. And I think what this met for me with the Gaze recommendations was that context that students already knew, so that when they were then looking at the graphs, they could then focus on what the graphs were telling them and how the different features of the graphs might give that information. And then soon after, we were going to do an activity in class where they were getting used to our Guru technology. And my fall term, I had actually used canned data, and it was actually probably more relevant in that the features of the box plot and the histograms were very carefully chosen. But because there were two court statistics courses running and we both used the same survey, we were able to just ask the question, how do our statistics classes differ? And so I think what I lost in having a canned problem, I gained in student engagement, because in fall term, they just did the activity and turned it in, and maybe thought a little bit about what the shape of the data was. But in winter term, I really saw the students getting interested in how these might differ, and just what that might mean for these two different classes. And so I got a lot better responses when I used their data. I think it was interesting to hear them talk. In terms of relevance, I was concerned about sports data because I'm not a big sports person. I wasn't sure if any of them would be, but apparently we all like talking about ourselves. And so it became very relevant to my students to use their survey data as they were comparing these. And then the next activity that I used the data in was linear regression. And in fall term, I just used like someone else's statistics class data set, and I didn't ask students to measure their foot. And then I realized, like, oh, if I'm going to do a predicting height from foot length, I should have my students measure their foot as well. That makes the most sense because I'd already asked for their height. But what I did, and my colleague and I had already cleaned the data for the dot plots, but we didn't clean the data for the foot length. And so my students were then faced with that. This was the one place where, besides their project, where I had them in class working on an activity in class where they had to clean the data before they could actually use it. And so there were missing values because some people didn't respond. Somebody put in 10 inches, so they had to do some unit conversions. There were outliers. We couldn't figure out there was one that we felt like maybe was just missing a decimal, but the 125 were like, they didn't mean 12.5 centimeters. They didn't mean 125 centimeters, surely. So there was this moment of like, yeah, what are we going to do with that? I guess we're going to discard that data point because we don't know what that student meant. And then in our guru in particular, once data comes in and it labels it as nominal, you have to change it to numerical. So obviously, if they were using coding, they would have to do that too. But it was just a good moment for us to, in class, have them realize that they're going to have to change the data type before the linear regression software would actually work. And we did that in class before they had to face that when they did their project later in the term. So I felt like just in and of itself, because it was this new class and I hadn't taught it before and I wasn't sure how to do real data. I felt like the class survey hit the, meaningful and engaging real world features like outliers and missing data and background information that they already knew, a question about themselves to support their interpretation and application. And it felt like a really easy on-ramp for a brand new statistics teacher. If I hadn't seen the survey tied with activities, I wouldn't have been able to bring that into my class so quickly. So I really appreciate that. At the end of today, I also have questions for you. So at the end of the rest of this talk, if you have survey questions and corresponding activities that you think work really well together, we'd love to hear those to be shared at the end. So authenticity. Fortunately, in the winter, I was accepted with the EA Post Scholars Program, and Beth started mentoring me. Thank you, Beth. And she helped me with several activities that were more in the decision-making realm. So with Bob and Tim, if you haven't seen it before, there's pictures that are composite pictures that people thought what a Bob would look like and what people thought a Tim would look like. And then the researchers then asked other people, or at least I did in my class, which one looks more like Bob, or which one looks more like Tim, who's the Tim. And so what we did in our class in the winter was we actually did a cluster sample of gen ed math classes at LB because I knew I could lean on math instructors to let my students come survey their students. And my students just went to the door and surveyed at the door, like, is the picture on the left Bob or Tim, and just marked it down really fast. And afterwards, I realized I should have switched up whether it was left or right. I didn't randomize which side the picture was on, but it was my first time and it was my very first study. So here we go. And my students didn't mind that much. So my students went to different classes and they surveyed. And actually at LB, out of the 45 students surveyed, apparently it was a Friday and not very many people were coming to class on that Friday. 36 out of 45 matched Tim with the name Tim. And so then we did the coin flipping in class. And this was our very first intro to inference. Actually, I need to give that context. So in Intro to Modern Statistics, they do an intro to inference where they talk about the idea of hypothesis testing and confidence intervals with simulation. And then they do theoretical math models. And then they come back and go through more systematically one proportion inference, one single mean inference, and so on. And so this was just my students' very first introduction to inference. And it really helped that they were engaged in collecting the data to understand what these dot plots represented. So after they flipped the coins, they knew we had a 45-person survey. They knew that when they flipped the coin 45 times, one of their dots represented a survey where the population didn't have a preference or didn't facially stereotype. So I found that combining the students doing the survey and doing the simulation really helped navigate those questions of what were we doing and what does this dot plot mean and what does the sampling distribution mean for the null hypothesis. And then we came back, we looped back to it when I introduced confidence intervals. So just that same simulation based. And I brought in black beans and white beans, which I really wanted marbles, but it became like a size problem. And there was a little bit of bias in our beans. I think the white beans might have been a little smaller, but then my students were also fishing for the one that was less likely to come up. So, the simulation was a little bit more interesting, but everybody had their bag of 45 beans. And what was really great about this activity was that later, when we were talking about other statistical methods, I had students suggesting simulation, like how they could maybe model that scenario with a combination of coin flips and pulling beans out of a bag. So I felt like returning back to the same survey that I had used already and introducing this so they knew the context, they weren't, that cognitive load was a little bit lower. It really helped students focus on this new simulation and what all of this meant. When we actually got into single proportion inference, we did use Reese's Pieces, and Wikipedia claims that 25, I wanted to choose a proportion that wasn't 50-50, and I still wanted students to do the data, but they were now going to do confidence intervals using the simulation and the central limit theorem. So it was new. And they then each posted on the board. So each group did 50 Reese's Pieces and saw how many yellow they had, and then created a confidence interval from their sample. And then we put our confidence intervals on the board so we could see the variability. And Beth did this great thing where she fixed the applet so that you could choose yellow to come out instead, which she did after the fact. So I didn't use this applet, but next time I will. Actually, I'm going to do this in a Stats for Engineers class, this same example for a proportion. And so then you can get the yellow sorted out. So now the Reese's Pieces applet, you can choose whether you want yellow or brown or orange, and have your students simulate if you want another proportion inference example. I'm going to briefly mention, oh yeah, one of my students said that if her brother had been in the class, he wouldn't have been able to be a part because he has such a severe peanut allergy that he couldn't be in the same room as the Reese's Pieces. So do watch out for that. It didn't even occur to me that that could be a thing. I knew they didn't have to eat them, so I thought I was safe, but just be aware that that can happen. And then I also added in for the single mean the human body temperature, and just quickly took their temperatures right after a test. And then we used that data. And Lance Bryant did an EO Post webinar earlier. And so I just borrowed his activity and changed it for our Guru instead of Minitab, and framed in the 6 steps of a statistical investigation. So my first term, the survey was my on-ramp to okay, I can get 3 of the 4 GAYS recommendations, just with the survey and activities that went along with it. So that was super helpful. And then with Beth's mentorship and other help, I was able to actually bring in some decision-making that I didn't have before. So I would be interested, because I found that survey so helpful, in what you use in class, and survey questions you might use that are connected to actually where you use it, and what kind of what the student data often is able to illustrate for you. And now I have to look for my chat too. Sure, I found myself requesting access on your Getting to Know You survey. Are there particular questions?
Oh, shucks, I thought I had it set up right. I'll look at it and revise.
Great. Are there particular questions? Are there particular examples you found certain questions illustrating, in exploring data, or that worked really good for a mean inference or something like that?
Yeah, so one of the recent revisions that we did was try to intentionally ask questions that would give us the ability to do a positive regression, a negative regression, build a confidence interval around. I know when I was working with Beth on some of the information, we were looking at some categorical variables, and it looked like, people who preferred cats versus dogs were more likely to prefer winter as opposed to summer as their favorite season. There's also one place that I looked to kind of think about variables was US Census at School, which I've used in high school classes a lot, but they ask the students a lot of different questions, and can be kind of like a jumping off point of what would relate to students.
Nice, thank you. Nice, Laura. When you were looking at how much time students are spending studying, did you just do that for your students, the students in your classes, or were you able to get data on?
Yeah, just from my class or all my classes. So I think I had maybe 40 or 50 students, and yeah, just collected by hand the amount that they spent for one particular week. So we also talked about like, well, we only know about week 5. You know, we don't know if like week 6 people will study more, that kind of thing. But they were like, it was really funny because they were like embarrassed and giggling, which was because they always say they have too much homework, and then I'm like, well.
Love it.
I have a little different question, Nicole, for you. I know I've done these in the past, and I will say I probably of late have been a little more worried, maybe more than I should be, about, I'll say, sensitivities with the students. And so, like, even your haircut question, I mean, again, I think historically would have viewed that as like this is kind of a chuckle moment, right? And an interesting discussion about an outlier. And maybe the person kind of self-discloses. But I think, I don't know, I guess I'm just curious if you have are there some rules that you use when you think about these questions? Have you run into cases where you're like, oh, somebody's kind of embarrassed on this one, like maybe we won't use that one again, or for others, I guess the same question, like how do you know where that line is, right? I mean, there's clearly some stuff that we'd say, well, we're not asking that on a survey. And I mean, it's anonymized to an extent, but like there's only 20 students in the room or whatever. So just curious for yours or anyone else's thoughts on that.
I think it was important for our, I didn't know what kinds of holes I would fall into. And so I was glad that I borrowed questions that for the most part were okay, but it really helped that we had 2 classes. So two classes worth of data, and that made it a little more anonymous. And with that, the $350 haircut was not in my class, but in my colleague's class, apparently that's how one of the groups figured out which one was theirs. And they had it worked out. They just had a nice conversation of like, oh, it looks good. And that kind of information about the haircut. So that one apparently worked out. So we did not hit a big pothole there, but I could see how you might. But I didn't think I wanted to ask about gender, because there's in one of the applets, there's with the height and foot length, you can use the proportion, or you can group in the multivariables and then see that coefficient of determination increase when you subgroup by variables. And I just didn't know of a way how to ask it. I just didn't have time to look it up, and so I haven't added that to my survey for that reason yet.
Well, I really like that kind of trick of, pooling data across a few sections. I mean, I think, I know I've done that on other things when I'm like trying to show a simulation distribution. I'll pool it with like some results from another class, which may or may not actually be another class, right? It might be my made up simulated class that I want, but I feel like that is a nice way to add some obvious kind of buffer and anonymity to it. So cool.
Yeah, and like Beth mentioned, I used a previous term as well.
Yeah.
once I wasn't teaching at the same time with another colleague.
Right. Well, any other questions for Nicole or Julia? Comments on this? This has been great stuff. Or did you have anything else, Nicole, that you wanted to share?
Actually, I realized that I did want to collect the ideas in the chat for future. Is that a thing that gets saved when you save as
I'm the one who probably should know that, and I
Yeah,
had
yeah.
no idea. But okay.
Yeah.
Okay.
Because what I was thinking I might collect the ideas in the chat and add them to my slides so that if someone wanted to look at this and were new to teaching statistics, they would get some ideas for surveys. So if there's a way, or I can try to copy paste really quick.
No, I saved what we have now, and I'll save again at the end, and then Nathan will also get an email probably at the end.
Perfect.
All right.
Thank you.
We're covered. Wonderful.
So I did have one other question. Similar to what Nathan was asking about sensitivity to students, one of the quotes that has like stayed in my mind as I'm either like developing or evaluating content is you want something that is engaging to the students, but not so distracting that it's gonna take over. And I sometimes like Skew the Script has some very engaging topics, but they also can be civic minded, a little controversial, have, maybe get students sidetracked. It seemed like, at least as I was looking at the questions you were asking, you were tending to that nice balance that this was like going to get their attention, but it wasn't going to send them off into these debates or discussions. Is that something that you thought of, or can you speak to that?
I do want to say, and then I want Lori. I want to say what was so nice was copying someone who had done it before and had stumbled into those mistakes. So I was like, I'm so glad I wrote down Beth's questions. Thank you, Beth.
I stole them from somebody else too.
I don't know if I can comment on that, just because in my classes we do a lot of like social justice statistics, and we have projects and I have lessons that kind of mimic some of the activities here in structure, but look at real data that has to do with racism and things like that. And I mean, I know my students pretty well. We also have really small classes, and I do like a temperature check before we ever talk about anything about their opinions, so I'm not like throwing some students to the wolves that have been marginalized. But I think that it is engaging, and it's okay to have side conversations. And students have told us when we've done like interviews with them that they like learning about the world, so those are the lessons that they find interesting, or things that they didn't know about, or things that are going on today. So it can be scary, but I think it's totally worth losing 10-15 minutes at the end of class, because this is what we're here to do, is make citizens. So I don't mind the divergent paths that we take.
I did want to say one last thing. Thank you, Beth, for being such a great AA Post mentor, and thanks to the AA Post community for creating this for these venues, because when I came in, it was so nice to have so many people sharing their resources. So that sharing and share alike community with lots of resources and websites to go to has been really, really helpful for me. So thank you.
Well, thank you, Nicole, and thanks to Julie as well for giving back. I mean, I think part of the goal of this from our seat is, to mentor and then let you give back to others and at your own institutions and through formats like this. And I will also use that as an opportunity to say, and we're thankful to the National Science Foundation who, supports this through its grant funding. And so I think that that's just an important thing that we always try to acknowledge. But I think also probably importantly in the era we're in right now, where there's a lot of questions about, research funding and what to spend money on and such, to recognize that. And not that I know that things said here are necessarily going to make a huge difference, but just please keep that in mind as you look for opportunities to advocate locally and at a national level as well. I did put some other announcements on the slide. And I won't walk through all of these aside from just saying feel free to, if you want any direct links before we log off today, just request them in the chat. Sign-ups for these upcoming workshops this summer. I mean, there's one in a couple weeks down in Georgia. It's probably kind of a little close if you're not local there already. But for these others, let us know. We can get you information. We'll continue to use the Google group. If you're not on that already, please do let me know or any of our other leadership team know, and we can get you added to that. And then EA Post Scholars. For those of you who've done it this semester, feel free to request a slot again. For those of you who haven't done it, we'd love to see you next fall. The Google group is where we'll promote that application process. The main goal there is just some mentoring, some, I'll say accountability, some support, a sounding board, a small stipend that's not meant to sort of pay you for your time, but just say thanks. And that's sort of part of the grant funding. So please let us know on any of these things. We'd love to see you participate and engage in the workshops in person, online, EA Post Scholars, or if you've got anything else, feel free to use that Google group as a way as well to kind of network and throw your questions out to a broader community of like-minded folks who are thinking about how to make statistics teaching more engaging, more effective for today's students. So I think with that, unless there's any final questions, we'll say thanks again to our two presenters today, to the mentors, Beth and Soma, and to the other mentors and participants who are here today. Thanks so much for your time. Have a wonderful weekend.